Hi, hello everyone. Good evening. This is your Ameer sir, Master Teacher of Physics at Vedantu. Now you have to quickly tell me how you all are doing. I really know that you all are doing super good, isn't it? Okay, and super fine. But if I hear it from you, it is gonna be super amazing, right? Waiting for your answer. So, quickly make it to me and tell me. Hi, Dharaninga. Hi, Viji. Hi, everyone. Good evening once again. I hope you all are super happy. Hi, Prasanna. Happy hi to each and every one. I hope why we all are here, right? Here we are with the rapid sprint 2.0 and we have already completed the first chapter, which is electric field, right? I can actually show you the timetable which is going to happen in the in this particular month. Okay, so in the Jan 11th, which we have covered already, the electric field, and Garang sir have covered kinematics. So here we are with the Jan 13, and the today's topic is going to be what? Yes, it is going to be the electric potential. So we're gonna go in detail with all the concept, and we are going to discuss most of the amazing questions from this particular chapter, right? So I hope you all are ready and I hope you all got the questions, because every time we will be before coming live, we will be updating whatever questions we are gonna discuss in our Telegram group. You can also be a part of Telegram group by clicking on this link, because we'll be updating the questions. So before you come to the classes, actually you can make a quick revision, okay? And actually when you come to the classes, whichever parts you are having doubt from the questions, we can be clearing it up, right? So we have a hi Akilan. Okay, so I'm all good there, Nika. So thank you so much. Now I really know that you don't want to miss any of the classes from this channel or from this sprint series. So you really want to subscribe, because once you make a subscription, you will be getting the notification for all the videos which is getting uploaded here. Now itself, don't be lazy, move your cursor and just press on the subscribe button. Okay. So before we start with the session, one more thing that I have to tell you is very simple, that if you want any personal attention and if you really wanted to write all India level mock test, and if you wanted to do more number of assignments and a complete concept from each and every chapters before this JEE means happens, you can also be a part of the NEET or the JEE crash course of 2021, right? So it actually comes with the price of 10,000 rupees. If you can apply the coupon code of AMECC, you'll be getting just for 8,000 rupees. Oh my God. The entire chapter revision for 8,000, it's going to be amazing. So I think we are going to start with the session, right? Which means the very first question. Are you all ready for that? Are you all ready? So here comes the very first question right in front of you. Okay. So let's start discussing here. So how it is, right? So the potential in the region of a space near the point P, okay, so the coordinates of the point P is given -2, 4, comma 6 is V is equal to 80x square plus 60y square. Okay, so let's start with the first, or let's start with the point C, because the question C is the simplest one among the three sub questions. So the question is, what is the value for potential at the point P? So the potential function is given. How can you find out the value for potential if the coordinates of the point is given? It's very simple, because you know that the potential V is equal to 80x square plus 60y square. So if you want to find out the potential at the point P, you can substitute the points accordingly, where you can put x is equal to how much? -2, right? So it's going to be -2 the whole square plus 60 into what is the value for y of the point P? That's equal to 4. So 60 into 4 square, right? So this is 2 square 4. So 6 4s are, so sorry, 8 4s are 32. So it's going to be 320, right? 2 2s are 4, 8 4s are 32, so one more 0, 320. So plus 4 square, it is 16, 16 into 60, how much? 0, 6 6 are 36, 6 1s are 9, it's going to be 960. So 0, so it's 81280 with the unit of volt, right? So this is the answer for the potential. I hope it's clear to everyone. right? So we are discussing the theory in deep. Don't worry at all. Okay, Vijay? Yes. So shall we go for the very first question, which is the first sub question, right? Okay. So I think it is better we can remove this. I'm just removing this as you can see it here, right? And let me continue with the very first question. Find out the electric field vector in the region. From potential, how can I actually find out the value for electric field? How is it actually possible? Right? Do you remember the formula? Let me tell you the formula. Right? The value for electric field, which is a vector quantity, potential is a scalar, electric field is a vector, is given by negative of dou v by dou x I cap plus dou v by dou y j cap plus dou v divided by dou z k cap. Oh my god. This is the equation to find out the electric field. I know that dou by dou x, which we call it by the name of partial differentiation, most of you might be listening to this for the very first time, right? So let's understand how can we actually do the partial differentiation. It is very simple, right? Partial differentiation means once you do dou by dou x, you are actually doing differentiation by considering only x as the variable here. Rest of the variables is considered to be a constant. I'll tell you how it is. So here it is v, and let's do dou by dou x of v, right? What is the value for v? It is 80 x square plus 60 y square, right? Okay, so here, so that is dou by dou x. So as I have told you, here x is the only variable, y is all the other variables are considered to be a what, a constant. So if I try to do dou by dou x of 80x square plus dou by dou x of, if I take this inside the bracket, 60y square. So while you deal with a partial differentiation, x is a variable, 60 is a constant, y is a constant, right? So if you do the differentiation of that constant, it's going to be 0. So the only thing what is going to remain is dou by dou x of 80x square. 80 comes out, right? Dou by dou x of x square, it is 2x. So that is going to be 80 into 2, that is 160x. So I'm going to write negative of dou by dou x of v is equal to 80 into 2, that is 160x with what, I cap plus, right? Don't you want to do the second term also, dou v by dou y? So that is dou by dou y of 80x square plus again 60y square. Not writing it completely because dou by dou y of 80x square, x is a constant here while you are doing the partial differentiation with respect to the variable y, right? Okay, so dou by dou y of 80x square, it's 0. Now, what is remaining? Dou by dou y of 60y square. 60 comes out. Dou by dou y of y square, it's 2y. So that's going to be 60 into 2, that is 120y. Okay, so I'm going to replace dou v by dou y as 120y with a j cap. And last thing we don't want to do actually, because dou by dou z of v doesn't have x here. So sorry, it is the partial differentiation with respect to z. The potential doesn't contain the variable of z here. So dou by dou z of 80x square, it's 0. Dou by dou z of 60y square, again it is 0. So the last term it's going to be 0. So the value for electric field is minus of 160x plus 120y. Is it clear to everyone? Santosh, Shankar, Dhananjay, Prasanna, everyone in the classroom. Is it clear? Okay. So I'm going to move forward, and we're going to do the B part, which is find out the electric field vector at the point P. So now we have the value for electric field. Let me rub this out. Okay. I hope you all have copied it down. Now, what we are doing is we are doing the option B, which means the question B, let's say. So find out the electric field vector at the point P. So the electric field is given by minus 160x plus 120y j cap. So the value of electric field at the point P is equal to negative of 160 into what's the value for x, that is equal to minus 2 I cap plus 120 into y j cap. What's the value for y at the point P? That's 4 into j cap. So this is negative of 160 minus 320 I cap. 120 into 4, that is equal to 480 J cap. So this is the answer going to be for the question. So we have covered all the sub questions from our main question. I hope it is super clear to everyone in the classroom without having a single doubt, right? So again, you can watch the replay. If you have any doubts, get it cleared before you leave the class. Okay, so after the class also you can watch the replay and get it cleared. And because this has got lot much of information and a lot much of concepts in it. So we are moving forward. Okay, great, Dharanjay. Okay, it's Dharaniga, right? Okay, I'm really sorry for that. So moving on to the very next question. What is it? Let's consider. So the question is, consider a point charge plus Q. So whenever you get a question, the first thing what you have to do is try to represent in a pictographical manner, right? So you have a point charge of plus Q placed at the origin. So you have the plus Q charge and another point charge of minus 2Q. So it is minus 2Q is here placed at a distance of 9 meter, which means the total distance between them is 9 meter. All good, right? Okay, the question is determine the point between the two charges. Between the two charges, we have a point, right? Let's say a point A, where the net electric potential is zero. So at the point A, the net electric potential is zero. So you have to find out the distance to that particular point. How can we do that? First, you should be knowing the potential produced by a single charge. What is the equation of a potential produced by a single charge? So the value of potential is equal to 1 by 4 pi epsilon 0, the charge q divided by r, where r is the distance to the point from the point charge. I hope everyone knows this. So the net potential at the point A is produced by this positive charge plus Q and the negative charge of minus 2Q. So the total value of potential is equal to the potential produced by plus Q plus the potential produced by minus 2Q, right? What is the potential produced by the plus q? Let's say the point A is at a distance of x from the plus q charge and the total is 9. So how much distance will it be there? Will the point A will be from minus 2q. It is going to be how much? 9 minus x, because total is 9. Here we have already used x. So the remaining is 9 minus x. So the potential from the plus q is equal to 1 by 4 pi epsilon 0. Let me write it as A, right? So the charge is a q itself and the distance is, let's say, x, plus what's the potential produced by minus 2q? K. The charge is minus 2q divided by the distance from minus 2q to the point A. That's 9 minus x. Okay, so at the point A, it is given that the potential is 0. So the net potential, I'm writing it as 0. So rearranging, okay, if I take this negative to the left, so that is k 2q by 9 minus x is equal to kq by x. K cancel, q cancels, right? So what it remains is, let me write it here, right? Let me write it here. So 2 divided by 9 minus x is equal to 1 by x. So 2x is equal to 9 minus x. Taking x to the left hand side, that is 3x is equal to 9. So the value of x is equal to 9 by 3, which is 3. So the distance of the point A from plus q is equal to how much? That is equal to 3, and the remaining is equal to how much? The remaining is equal to 6. So I hope you all got it, right? That was a very simple part. Now, moving on to the very next question. Okay, so give me 1 minute because we lost the content here. So give me a minute. Sorry for the trouble here. Okay. So we are having a small trouble with this. Yes. So we are done. So we are ready to go. Give me a minute. So we'll be live soon with the very next question. Okay. So the slides are getting uploaded. So I hope till here, whatever we have discussed, everything is clear. No doubts, I suppose so. Yes, we got our slides. So then why we have to wait? Moving to the next question right in front of us. Okay, everyone, cool here. So what is it? We have a charge of minus 1 microcoulomb is located on the y-axis. So we have minus 1, which is a distance of 1 meter, right? And at the same time, and plus 1 coulomb, which is located on the plus x-axis, right? And the same distance of 1 meter, as you can see. It's 1 meter and 1 meter, right? Okay. Determine the value for the following quantities at the origin. So here we have the origin. At the origin, what we have to find? The first sub question says we have to find out the electric potential, right? Yes. So how can we find out the electric potential of a point charge? We have explained in the previous question itself. What is it? That is equal to 1 by 4 pi epsilon 0 q by r. But the net potential produced at the origin is because of the two charges here, because we have minus 1 microcoulomb and plus 1 microcoulomb. So the total potential is equal to, how much is the total potential going to be? The potential produced by the minus 1, that is equal to 1 by 4 pi epsilon 0 minus 1 into 10 power minus 6. What is this 10 power minus 6? Micro converting to coulomb, divided by r is equal to 1 plus the potential produced by plus 1 at the origin, that's equal to 1 by 4 pi epsilon 0. The charge is 1 into 10 power minus 6 by distance of the origin from the plus 1 is 1 meter again. So you can see that both the magnitudes are the same, but with the opposite sign. Once you add it up, the net potential is going to be 0. Okay, so that part is done. So the next part of the question, the energy needed to bring a minus 1 microcoulomb charge to this particular position, which means to this origin, from infinitely far away. So the energy needed, let us continue it here, right? So where can we write? Okay, let's write it here. So the energy required is always for what? In order to do the work, right? And the work done is always equal to the change in potential energy, right? And how will you write the change in potential energy? The charge into change in potential. We already have a very good basic idea regarding this, right? So the charge is taken from infinity where the potential is 0, okay, to a point where the potential is 0. So the change in potential is 0 minus 0. So Q into 0 it will become. So the energy required is totally 0 here. Is it clear? Right? Without having any doubts, I suppose it is super clear. Okay, so I think it's time for us to move to the next question over here. What do we have? Right. So it goes like this. The two parallel plates are charged here. So the separation between the plate is 2 centimeter and the magnitude of the electric field between the plate is 500 volt per meter. Value of electric field is given. What is the change in potential energy of the proton when accelerated from the positively charged plate to the negatively charged plate? Now, let's say that I'm keeping a positive charge here. This will be repelled and it will be moving towards a negative, which means that positive charge is moving from a higher potential energy to a lower potential energy, right? So the question is, what is the change in potential energy? Right? So that's equal to final minus initial. What's the formula for a potential? That's equal to charge into final potential minus the same charge into initial potential. So if I take the charge outside, it is final potential minus the initial potential, which is the change in potential, right? Okay, so that is Q into change in potential. So final minus initial, it is a negative value into delta. Okay, so why negative? Because the final minus initial, it is moving from higher to a lower. So final minus initial, it's a negative value. Now is equal to negative of Q. How can I find out the potential difference? Once the value for electric field at the same point is defined, it's very simple. You know that the potential difference is equal to electric field into distance between them, right? Okay, so this comes with negative of what is it? So the potential energy of proton, right? So that's equal to 1.6 into 10 power minus 19, right? What's the value for electric field? It's a 500 and the distance is 2 centimeter. So 2 into 10 power minus 2. 10 power minus 2, these two zeros will go off. 5 twos are 10, right? So this is equal to negative of 1.6 into 10 is 16 into 10 power minus 19 joules. And this is going to be our answer, which is the change in potential energy, right? Okay, super awesome, everyone. So I hope everyone is clear till this particular part. Now we have to move on and let's give you some homeworks. So these are the questions which you have to do it as homework. You have to do it thoroughly. Whatever theory is being discussed in this class, that is more than enough to do all these particular questions. So this is the first question. Okay, please do take a screenshot. And here we have the next question, which is our homework. Great. Yes. So the answers to these questions will be updated in the Telegram group. So you can come and join and be a part of this Telegram group by clicking on the link here. Right? Okay. Now, what I have to say is if you have liked the video, so please don't hesitate to press the like button. And if you think that, yes, your friends are also going to benefit it, share it with your friends. And if you don't want to miss any of the videos that we are uploading here, right, which contains lot much of concepts and information for helping you to get an amazing marks in physics, okay, don't hesitate to subscribe. Move your cursor, take it to the button of subscription, right? Subscribe now itself. So I hope you all enjoyed. Next time we'll be meeting with a new topic of capacitors on Friday at the same time. So I hope that we're going to meet all at the same time. So till then, bye bye. Take care.